Hello again, calculus people. We're about halfway through our review of the very important pre-calculus concepts in order to get ready for calculus. Today we're talking about inverse functions, and we're asking the questions, what are inverse functions? What are the inverse trig functions? How do we find the equation of an inverse function? And finally, why do we need domain restrictions? An inverse function is a function that undoes the action of the other function. So let's say we have this function f. Its inverse function would be noted like this, f to the -1. And if I take f inverse and plug it into f, if I like composite them, I don't think that's an actual verb, but if I plug f inverse into f and simplify, I should end up with just x left. And of course, I can reverse that. I can take f and plug it into f inverse. And if I simplify it, rearrange it, I should come out with just x in the end. We're going to start by looking at inverses graphically. So if I've got this function x cubed minus 1, first of all, can you picture a cubic function in your mind and then shift it down one? That's what it would look like. Its inverse function is the cube root of x plus 1. And that's what that looks like graphically. And you'll see that they are reflected over the line y equals x. And our f inverse, the blue one, does pass the vertical line test. So our f inverse is also a function. But does every function have an inverse function? Well, let's look at x squared minus 1. We've got an index of 2, so that's a parabola. And it's shifted down 1. Its inverse is kind of this piecewise function, comes in two parts, x plus 1 and negative x plus 1. And again, it's reflected over the line y equals x. However, it does not pass the vertical line test. Now we could have shortcutted this just a little bit by using, instead of looking at the inverse graphically and then doing the vertical line test, you can just use the horizontal line test. And see, that hits the graph in two spots. So if the horizontal line hits in two places, then the function does not have an inverse function. So a function only has an inverse function if there's a 1-to-1 relationship between x and y. Now let's look at these inverses algebraically. We're going back to our cubic function, x cubed minus 1. And to find its inverse, take the x and y values and switch them. So we've got x equals y cubed minus 1, and then just solve for y. So we've got y equals the cube root of x plus 1. Now, how can you verify algebraically that these functions are inverses of one another? Well, you composite them. You plug one into the others. So we'll start by taking f inverse of x and plug it into f of x. So we've got our f inverse, and then we cube it, subtract 1. Now the cube and the cube root, those undo each other. So we get x plus 1 minus 1, which is indeed, yay, just x. Now we will reverse that process, and we'll take f of x and plug it in here to its inverse. So we get the cube root of x cubed plus 1 minus 1, which is just the cube root of x cubed, which, yay, is just x again. Let's try another one, because sometimes, they get more complicated, and that's what we do in math, is we have to get more complicated. So we're going to switch the x and y values and then solve for y. So we're going to have to take this y, multiply it over, And then somehow we've got to get all the y's together. So let's subtract that y. And then factor out a y. And then divide both sides by x minus 1. And we have our inverse. Now we can verify that these are indeed inverses of one another by taking our inverse and plugging it in to the original function. So this is going to get nasty quick. Okay, so now we've got to simplify this. So if we're dividing by a fraction, we can flip and multiply, and then we can distribute that through. This is just a 1, right? And then these 2's cancel out. And you get 1 plus x minus 1, which is just x. All right, you ready to reverse that? Okay, so this time we're taking f of x and plugging it in for x. So yikes, how do you do this? So we've got to deal with the bottom first. So we need to find a common denominator in order to combine those bottom terms. So instead of a 1, I'm going to have just x minus x. Now I combine those two. So x plus 2 minus x is just 2. Flip and multiply. Those 2's cancel, and we're left with x. So we have indeed verified that f of x and f inverse of x, these guys over here, are indeed inverses of one another. Let's talk about inverse trig functions. So we're going to start just y equals sine of x. What does that look like? It's a periodic function. It goes up and down and up and down. And if we were to put this through the horizontal line test to see if its inverse is also a function, well, it fails the horizontal line test. This is not a one-to-one function, so sine's inverse is not a function. However, if we shrink it a bit and we bring the domain to just between negative pi over 2 and pi over 2, we'd get a range of negative 1 to 1. And its inverse, graphically, is arc sine of x. And look at this. So the range just becomes the domain, and the domain just becomes the range. So what we're seeing here is that under suitable conditions, if we restrict the domain, actually each of the 6 trig functions can be one-to-one and can have an inverse function. So we will stop there for now. And I'll see you next time for our last pre-calc review. Thanks for being here.